Hi everyone, welcome to Lesson A, Part A of Lesson 8. We're going to take a look at the graphing of the inverse relationship between exponents and logarithms. So if we take a look at our document, the exponential form, y equals b to the power of x, we've taken a look at that graph. And then we have the logarithmic form, so this is how they're related. Y equals the log of x to the base of b. So the relationship is this. All right, so if I should replace that b, if I have 2 to the power of x, that's equivalent to the log of x to the base of 2. All right. These functions are inverses, and what that means is that they are a reflection of each other in the line y equals x. So here I've labeled, here's our line y equals x. It goes diagonally through the middle of a set of axes. And then we have our function here, y equals 2 to the power of x. And then we have our log function right here, which is the log of x to the base of 2. Okay, so hopefully you can see that one is the reflection of the other, meaning that it is the inverse function. So I want to try to look at completing a table of values for the given function. We have y equals 2 to the power of x, and I'm giving you all the values, all the x values that I want you to use. We'll use a table of values to find all of our y values. So y equals 2 to the power of negative 2. So that y is equal to 1 over 4. Remember, a negative exponent is the reciprocal. And then y equals 2 to the power of negative 1. And that's going to make a half. And then y equals 2 to the power of 0. And anything to the power of 0 is always 1. Y equals 2 to the power of 1 is 2. Y equals 2 to the power of 2 equals 4. And finally, y equals 2 to the power of 3, and we have 8. So I'll fill in my table of values: 1/4, 1/2, 1, 2, 4, and 8. So that's my first table of values. The next function I want to work with is y equals log of x to the base of 2. So if I want to know y, I'm going to find the log of 1/4 to the base of 2. So how does this work? Well, remember when we were solving log problems before, we have then that the base 2 to the power of x equals 1/4. So we sort of change it from logarithmic form back to exponential form so we can work with this. We change the one side so it has a base of 2, and this is equal to base of 2 to the power of negative 2, and then therefore x has to equal negative 2. We'll do that one more time with you. So log of 1/2 to the base of 2, that's equal to 2 to the power of x is equal to 1/2. 2 to the power of x is equal to 2 to the negative 1, and therefore x has to equal negative 1. So negative 1 goes into my table. So you can keep doing the work here, but hopefully what you're noticing for the first 2 points, so for the log function, x is 1/4 and the y is negative 2. And for the second coordinate, x is 1/2 and the y value is negative 1. And if we scroll back up, we can see that for the function y equals 2 to the power of x, our first coordinate is -2 and our y coordinate is 1/4. And the coordinates for the second point, x is -1 and y equals 1/2. So they are exactly opposite within the two graphs. So you should be able to go back and fill in the last 4 values, even if it's just based on the table above. So graphing, so you're going to go back to Desmos, you're going to graph the functions, take a screenshot. If you do it on paper, you can also just take a picture of it. And the graphs that I'm looking for are y equals 3 to the power of x and y equals the log of x to the base of 3. I'd also like you to graph the line y equals x. And then I want you to identify 2 points that are reflections across the line y equals x. And you're going to put your graph in here. So you have 1, 2, 3 functions to put into Desmos, and you should be able to get something that looks like this, what we have at the top. So 2 functions, one's exponential, one's logarithmic, and then the line y equals x that goes through the middle, the diagonal. All right, and then we have a couple of questions at the end. Just use your graphs to help you determine the answers to these questions. So how does the domain of y equals 2 to the power of x compare to the domain of y equals the log of x to the base of 2? And remember, domain is a set of all x values that can satisfy both of these functions. The range, how does the range compare between the two functions? And remember, range is all the y values. Right? Next thing, I want you to describe what an asymptote is and what happens to the asymptote of the exponential function when it's reflected to create the logarithmic function or graph. You have a true or false question. Every exponential function has a logarithmic inverse. Is that true or false? And then try to explain in your own words how you can use the graph of an exponential function to sketch the graph of its logarithmic inverse. Remember, you can go back to those tables and see how the different points are similar or opposite. Next, you have a challenge extension. So use Desmos to help you graph this again. You have y is equal to 1/2 to the power of x. And then you're going to graph y is equal to the log of x to the base of 1/2. And then compare how the basis affects the steepness of the exponential versus the logarithmic curves. Describe the change. And the hint here is the base of an exponent. What do you expect to see when the base of an exponential function is a half or a decimal or fraction? All right, so go ahead and finish off that worksheet and then submit it when you're ready.